Hello guys, today we'll be solving Codeforces round 907 tip 2 problem B, Deja. Pause the video, read the question and then I'll explain. Okay. Yeah. Question seems to be very complicated, but it's quite easy. First, let's see the question, then we'll proceed to the intuition and then approach. Okay. So cool. So the question was saying that we'll be given two arrays, array A of length n and array X of length q. Now both will consist positive integers. Okay. And note that positive integer doesn't mean it will include 0. Okay. Now what it is saying that basically the q what we have received right now is kind of operation we have to perform. So basically there will be q modification, and on the ith modification what we have to do is, so it's better if I'll explain it over here. Just give me a second. Yeah. So what it was saying that the question says we have two arrays, right? So this is array A and its length is n, and we have another array X and its length is q. So now what it is saying that we will run a loop over this X. Okay, we'll run a loop over this X. So let's consider this something like this: for I equals to 0, I less than q, I plus plus. Okay. Now what we will do, so whatever we'll find out in this j, in this, in layman terms I would say that we'll iterate of this over this A, and then what we'll do, if at some places, or it's better if say, let's I it's better if I write something like this: I'll iterate over A, that is j less than A, j plus plus. And if if this A of j, if this A of j modulo, or I would say divided by this power of 2, that is divided by power 2 comma whatever the value we have for this ith query of this X, that is X of I. If this modulo 2 equal to 0, then we have to update this A of j is equals to A of j plus 2 power X of I, whatever the value here, or if you want to write it something like this, yeah, 2 power X of I minus 1. And after performing this operation, so whatever the final value of A, we'll have to return that. So what we are doing here, right, if you'll see, what we are doing is we are taking one value or we are going line by line. Okay, first we are taking the first value, we are checking if it can divide any value of the A. If yes, then we'll update the value, else we'll continue. Then we'll move and pick the second value. Okay, so the important thing to note over here is what we are saying, that whenever we are saying that if A of I, or as per my explanation, if A of j is divisible by 2 to the power X of I, okay, then in this scenario we'll replace A of j by A of j plus 2 to the power X of I minus 1. Okay, so now instead of I and j, let's write it something like this. So let's say if A of j I was, sorry, A of j was p, and it was divisible by, let's say, 2 to the power 3, or what I am trying to say is x to the x of I is, let's say, 3. Okay, so what our first statement is p modulo 2 to the power 3 equals to 0. Yep, this is correct. Okay, then what we will do, we will replace this p by p plus 2 to the power 3 minus 1. That's what the question says. So just watch this carefully. What I am trying to do over here is, so this can be written as p to the power 2, and this will be equivalent. We know that this p was divisible by 2 to the power 3, right? So can't we write it some m into 2 to the power 3 plus 2 to the power 2? Can't we write it? If this p was, we already assumed, right, we know that this p was divisible by 2 to the power 3. That means this p can be written as some integer m multiplied by 2 to the power 3. Okay, plus 2 to the power 2. Now if we'll take 2 to the power 2 common, what we'll have? M into 2, because we have taken out 2 to the power 3, so there will be 1 2 remaining and 1 over here. Now, this is the most important observation for this question. Now, if we'll see over here, what do we have? This is 2 to the power 2, okay? And this is an even number. Watch carefully. This is an even number, this is an odd number. So 2m plus 1, this is overall, what this will be? This will be an odd number. So, and this is 2 to the power. So what we assume that p was divisible by 2 to the power 3. And now we can see that it is not divisible by 2 to the power 3 or any power greater than 2 to the power 3. Why? Because we know that this is 2 to the power 3 and this is some odd number. So this is some odd number, that means it cannot be written as 2 to the power some form, right? In the form of 2 to the power y, it cannot be written down. So the only 2 to the power, so whatever the numbers we have, we can all, or this the final number can only be divided by 2 to the power 2, or whatever the value is lesser than 2 to the power 2, that is 2 to the power 1 or 2 to the power 0. Also in the question it is mentioned that the values are positive, so we can ignore them. So that means this can be divisible by 2 to the power 2 or 2 to the power 1. Now another object, let's proceed this. Let's say if p was divisible by 2 to the power 5, then same we can write, then the updated value will be p plus 2 to the power 5 minus 1, that is p plus 2 to the power 4. And we know that this p can again be written as p into 2 to the power 5 plus 2 to the power 4. Again taking out common 2 to the power 4, what we'll have? 2 to the power 4 common 2m plus 1. Again we ended up in the same situation, that if this is odd, then we know that this can only be divided by 2 to the power 4, 2 to the power 3, 2 to the power 2 or 2 to the power 1. So what we realize over here is, if xi is, let's say, 5, then once we have performed this operation, so let's say for this, if a of j was divisible by 8, that means next value it can be divided, or the next value this will be divided is less than equal to 5, right? Less than 5, not equal to 5. So once it is divided by 2 to the power 5, then it can only be divided by 2 to the power 4 or lesser values. Okay, so we know that in the from the question itself, we know that the values won't exceed 30 here. The value won't exceed 30. So let's say if for particular I, a of I, it was divisible by 2 to the power 30, then whatever the result we'll have, the result will be nothing but a of I plus 2 to the power 29. And we know that this will only be divisible by 2 to the power 29 and 2 to the power 29, and the result from here will can only be divided by 2 to the power 28 and lesser values I forgot to mention, but lesser values can also be divided. But if it is divided by 2 to the power 28 once, then it's not going to divided by 2 to the power 28 again. It can be divided by one particular power of 2 only once, right? So at max what we can say that a of I can be, for the first time, can be divided by 2 to the power 30. I'll just write down 30, and then like 29, then it's 2 to the power 29, then 2 to the power 28, till 2 to the power 1. So we know that for one of AI or for particular value, we can have at max 30 updation. We can have at max 30 updations, right? Right. So initially, what when we started, if we would have run the loop, something like this, the n square solution, it will be like n into q solution, which is like kind of O of n square or 10 to the power 10 solution, because both are of the order 10 to the power 5. So in this would have give TLE. But now we realize that for any AI, we can update its value at max 30 times, so if somehow we find solution into 30 of n or 30 of n, so it will be nothing but big O of n, which will be an accepted solution. So now the real question is, how can we remove that second loop, knowing the information that this AI can be divided only by 30? So one more thing, we know that we are applying the modification in left to right fashion. So like whatever the lower index, we'll have to apply that, then again that, and again. So if I have any number, so let's say, I mean, see, the length of x can be 10 to the power 5, right? It can go up to 10 to the power 5. That means I'll have something like this 2, and then again I'll have 2, then again I'll have 2. Okay. Similarly, I can have 4, 3, any value. Let's say 10, 12. Again 12 is repeated. Let's say again 10 is repeated. Now the question is, we know that if I'll pick 2, let's say if I have some value and it is represented as 2 to the power 10 multiplied by some f. So we know that we can, and yeah, the x of I was the power of 2. So though it's written 2, it's 2 to the power 2 we can consider, and 2 to the power 3, something like that. Okay, so we know that if a of I is 2 to the power 10 into some odd number. Okay, so what we can say that if we divide it by 2 to the power 2, then then what will happen? Then what will happen if we divide it by 2 to the power 2? Then whatever the updated value we'll have can only be divided by 2 to the power 1, because anyways we are ignoring 2 to the power 0, right? So so but we know that here it was 2 to the power 10, and we could have divided it by 2 to the power 3, or 2 to the power by 2 to the power 10 itself. Then in that scenario it could have, let's say here it was 9 or 8 or 7, anything. So if we would have divided by directly by 2 to the power 2, then we might have missed these values, right? We might have missed these values. Okay, so and yeah, why we are worrying about this? Because we have to, guarantee that there will be maximum values. Sorry, not the maximum values. What will be the total value? What will be the final value? And the reason for considering is, let's say if I am picking this two, right? Sorry, I got a bit confused. It's not like we can pick this two because this was the first in our line. So whenever we are starting this, we'll have to pick the first element that divides this x. I mean, there can be, if it's, let's say, 2 to the power 10, but I have numbers and the x is starting something like this, and then finally I have 10, or let's say 8 over here, then I'll have to choose these 8, right? Because though I can have better elements, but I'll have to choose this. So what I will do, that for this x I'll run a loop. So for I run a loop, I less than n, I plus plus. Now I know that let's say c is equals to a of y. Now I'll have to find that this c is divisible by which power of 2. That is, let's say कि c modulo 2 to the power some y equals to 0. Then what I'll have to do, because we know that if I am able to find the biggest power of y, or not biggest power, I would say all the values of c, all the values of y, such that c modulo 2 to the power y is equals to 0, then whichever values comes first in this x array, right? So I mean, let's say, let me pull over here. So let's say if I have c is equals to 2 to the power 5, okay, and then I have some values like this, let's say 7, 8, 3, 2, and 5. So though 2 to the power 3 can also divide, 2 to the power 2 can also divide this c, and 2 to the power 5 can also divide, but the first operation will be performed by this 3, right? So if this 3 will perform the operation, that means next time this c, let's say it becomes c dash, can only be divided by 2 to the power 2 or less. So how so what we need to do is, first of all, we'll have to find out that, okay, for this c, which number or which position it can be divided first, and then we can move to the next position. So what I am trying to say is, let's say if there are so many threes, okay, and then I have two, okay, or let's say I had few fours and I have 7, 8. It does not need to be sorted, it can be anything, something like that. So we know that, let's say if I have divided something by this 4, that means, or let's say if I have divided by something by that 4, that means the next time that number can only be divisible by something is smaller than 4, something is smaller than 4. So whatever the next we have in line will be the next time that element will get modified, right? So let's say here itself, if, or considering this example only. If c was 2 to the power 5, so if we apply or perform this first operation, will it affect it? No, that c will remain as it is. Will this 2 to the power affect it? No. Will this 2 to the power 4 affect it? Yes. Now c will become something like this: 2 to the power 4, sorry, 2 to the power 5 it was, right? So we can simply write something it like this one: 2 to the power 5, right? Let's say it was m 2 to the power 5. If we'll divide it 2 to the power 4 and add 2 to the power 3, right? So it will become, sorry, we don't need to divide it 2 to the power 3, we can simply add 2 to the power, sorry, I'm saying wrong. No, we don't need to divide it by 2 to the power 4, we simply need to add 2 to the power 3, because that's what question says, that we need to update the value by 2 to the power x minus 1, xi minus 1. So 2 to the power 5 into m can be updated to 2 to the power 3 into some odd number, right? Some odd number. So we have to find the next smallest element. Let's say if there was no 3, no 3, okay, then this can only be divisible by the numbers which is smaller than or equal to 3, right? So the next number which is smaller than equal to 3 is 2. So for somehow what we will have to do is that if we are at this 4, we will simply go to this place, right? We'll simply go to this place or the next smallest number. So from here what we can say that we'll have to store, because see, why I am saying so, why we are saying so, because we know, see, we saw over here that if we have divided by 4, then we can divide it by 3, but there was no 3. So we moved further and tried to divide it by 2. If we found 2, yes, we can divide it by 2. So if we'll realize what we are trying to do is we are trying to find the next smaller element in its right. Okay, so let's say if I have performed some operation and here is 5, right? Then the next time I can perform operation by any number less than 5, and we know that whichever number comes first in this position, whichever number comes first in this order, or first in this remaining order or remaining sub array or array, then that number will divide it. So if it's 3, even though we have 4 over here, this 3 will operate first, this 3 will operate first. Okay, so first it was divided by 5, and let's say here it was 7. Then the next time it will got divided by 3, and the next time, if let's say here it's 7 in it, then it won't get divided any further. It won't be divisible by, okay, it won't be divisible by any number further. So that will be the last time we will update its value. So what we are doing is, first we are trying to find out which number or the first index where it is going to be divisible, and here then we are moving forward. So we'll have to store the next smallest element in this, from in the right. So in the right, next smallest element for all the elements. So even if there was so many 5s and there was 4, I will simply jump from this 5 to this 4. I don't need to go to this 5, because I know this 5 can't divide it. Okay, that's why we are storing the next element. And if it, let's say here it was 7, 8, and there was 3 or 2, then I can simply go from this 4 to 2, because I know that this 2 will only be able to divide it, not 7 and 8. So what we'll realize, that we already know that in x maximum value can be 30 and minimum value can be 1. So if 30 divided, then we will move to 29. It doesn't matter how many values are there. Then if 29, then 28. So now another question is how we'll find this one. So that's a very separate problem. You can read it about it. That is, next smaller element, in right. It's a very famous question of stack: next smaller element, next greater element in the right or in the left. So this is a very famous question. You can search it out on the YouTube. You'll find many good videos. But if you guys still need my help on this, I'll just drop the comment. I'll make a video on this as well. So let's say now we have this smallest element array. Okay, now what we'll have to do, so we will simply run this loop. Okay, and yeah, what we'll do, see, we always need, let's say if we know that this c is divisible by 2 to the power 5, this is c is divisible by 2 to the power 5. In this x array there are 5 at 3 places. Let's say this one and in the last position. So we know that we are performing operations or modifications line by line. So when we will come to this 5 itself, then only it will get modified, right? So we'll have to for each value, that is from 1 to 30, because we know that the values are only 1 to 30, we'll have to find out which values are stored at which place for the first time. So like for this one, I'll have the index of this 5 stored in a map. For the timing in a map, I'll store this index. Okay, so what needs to be, I'll now you know try to compile all the concepts. So what we learn, first of all, we know that a of I can be divisible by can be modified at max 30 times. Okay, we'll have one map. What will that do? That will store the index of 1 till 30, 1 till 30 in the yeah 1 till 30 in such a way that the first occurrence is recorded. Okay, now we'll also calculate the smaller to the right. Okay, smaller to the right. Okay, now if we have all this information, before this all this information, what we can do, we can simply run a loop for I equals to 0, I less than n, I plus plus. Now let's say c is equals to a of I. So for this c, what we can do, we can simply run a loop for int I equals j equals to 1. Why I'm doing this, you'll just get in a minute. Less than equals to 30 j plus plus. So I run a loop something like this, and what I'm saying is if this j should be present in map, and in map what we have, the initial index or the first occurrence index of any particular number. So if map.find j is not equal to map.end, that means we have that particular element in our array or the x array, and if this value, whatever, if this c modulo 2 to the power j equals to 0, then we'll have, yeah, I forgot one thing, we'll have one more, that the divisor or the first divisor index for this c. So let's say it was at the end, that is q, because the size of x was q. So let's say it q plus 1, then we can simply minimize it. D is equals to minimum of d comma whatever value we have right over here, right, that is mp of j. Okay, so in that from this loop, with the help of this loop, the second loop, this one we can have the first divisor of this c. Now we have this first divisor of this c, then what we can do, we can simply run a while loop, that while this divisor is less than q. Okay, because after q there will be no numbers, right? Then this a of I can be simply modified to a of I plus is equals to power of 2 ka power whatever this j we have, whatever this divisor we have, that is 2 to the power d minus 1, right? And then we can simply replace this by, we know that the index of this, or whatever the index of this and the next smaller element for this particular index value, or this for no what I'm trying to say is, if we had this divisor over here and its value is 5, for this 5 we need next smaller element, right? So we can simply write, and for this position we have, and this was position exactly, so not exactly here it will be 2 to the power d, it will be something like x of d, right, x of d minus 1. And we know that the next small element for this dth position is stored in, let's say, smaller. Okay, then we can have smaller d, right? You can simply update something like this, and finally this a of I will be updated to its final value, and we can move on. So that was the whole approach for this question. Let's move to the code first. Yeah, that's one. There is one thing, that instead of calculating power using power function, I have written a separate, I have made a separate vector and calculated it for all the test cases here itself. Okay, so we can just simply write power of 2 ka power I is power I. Okay, so, and this is the function to calculate the smallest element in the right, first smaller element in the right. Then we simply took the input in array and x vector. We stored the occurrence, first occurrence of all the number in the X. Then we have this smaller element as we talked in the discussion. And then we perform the same thing. We first find out the first element, first divisor, and then we checked it and updated the divisor and finally print its value. Okay. It was a submit AC solution. Cool. I'll share the link to the solution as well. I hope this I explained well, and you guys have got the context. How can we solve this problem? But if you guys have any doubt, let me know in the comment section. Okay. Thank you guys. See you in the next video.